I'm not sure if you are Lord of the Rings fans or not, but there's a rumor that there's a long-lost chapter of the Lord of the Rings where Gollum finds out that he can have even more power extracted from this ring if there's an induced current in it. And specifically, he finds out that his hair will spontaneously grow back if only it has an induced current of specifically 3 milliamps. All right? It's a true story. It's a true story. If the ring has a diameter of 1.5 centimeters and a resistance of 1,000 ohms, then at what rate in Tesla per seconds would he have to change a magnetic field to achieve the induced current necessary for this new power in his ring and have his hair grow back? There's nothing personal here, I promise. All right. Well, what do we know? We know that I is equal to V over R. Correct? And we know, furthermore, that this I must be 3 times 10 to the minus 3 amps. Right? Furthermore, we know that this V is really going to be the induced EMF, right, which we know is equal to the change in BA over delta T. Technically BA cosine theta, but I'm just going to go ahead and assume that, again, the area vector and the ring are going to be aligned with the magnetic field, and this is 0 degrees, so that's just 1, right? Which means that the induced EMF is really just delta B over delta T. In other words, this thing here, that is the rate at which the B field's changing. Delta B over delta T is the rate times A. Okay? So I can go ahead then and just put this in for this voltage. I could say that the current, right? Well, we know what we want the current to be, so I'm just going to go ahead and erase that. We want the current to be 3 times 10 to the minus 3. All right, and I'm going to go ahead and put this in for V. So that's delta B over delta T times A. And there's still that R on the bottom. Right, so I've just plop, and there's still this resistance on the bottom. Okay, which means that if we solve for the rate, if we're solving for delta B over delta T, again, that is the rate that we're looking for, then that should just be 3 times 10 to the minus 3 times R divided by the area of the ring. Right? Okay. Now, we know from the problem that the resistance is actually 1,000, right? 1,000 ohms. And we know that this area is the actual area of the ring itself. So that's going to be pi r squared. In this case, it says the ring is 1.5 centimeters, right? Or so the diameter is 1.5 centimeters. So 0.75 is the 0.75 centimeters is the radius. So that's 0.0075 squared. Okay? And if I put this in my calculator, folks, I get delta B over delta T. In other words, the rate at which the B is changing, right? I get a value of 127 Teslas per second. All right? So if Gollum can somehow find a magnetic field and change it at precisely 127 Teslas every second, which, granted, is quite a bit. It's probably why this never worked in the movie and why they had to take the chapter out. But if he were able to do this spontaneously, Gollum's hair would grow back, and there would be a beautiful head of hair, and maybe he wouldn't be so moody all the time. Maybe, right? So